Okay, so today we're going to be talking about acids and bases. So the first thing I need you guys to do, I need you guys to get a piece of paper. Your teacher should have this. Periodically throughout this video, you're going to have to pause it so that you guys can do a little bit of work on your little foldables that we're going to do here, okay? So we're doing acids and bases. First thing I need you to do, get a piece of paper. Let me pull this up a little bit so you can see. All right, so here's your piece of paper. I need you to fold it in like this, okay? So you've got to, whatever you call this, is this, I don't know if it's hot dog or hamburger way. I don't know that stuff. So you're going to take it and you're going to fold it here, make a crease, and you're going to fold it here and make a crease. So that when this opens up, it's going to open up like a booklet. You see it? Okay, great. Now, after you've done that, I want you to label, so I'm going to make this, bring this down just a little bit closer for you. Okay, so you're going to label the top of these. This first one you're going to label as acid, and then over here I want you to label this one as base, okay? And so these are going to be your properties of your acids and your bases up here. All right, so some of the properties of acids is that you guys all know this, most times your acids have a sour taste, okay? And so a lot of times these are your limes, your lemons, even sometimes your what is it called? Oranges, things like this, okay? So they're going to have a sour taste. Now, over here, your bases, they're going to taste very bitter, okay? And so if you guys have ever gotten soap in your mouth when you're in the shower or something like this, that's that kind of, that bitter taste is what a base is, okay? Most of your soaps are basic. Okay, so next thing we want to talk about, your pH, okay? So your pH for your acids are going to be less than 7. So what do you think that means for your bases? Over here, your bases, your pH is going to be greater than 7, okay? So 7 is actually the point where it's neutral, okay? Your acids are going to donate, this, we're going to say this is an H+, but we also call this a proton, okay? And your bases, guess what they're going to do? Anybody? Bases are going to accept your H+, or accept, in this case, it's a proton, okay? All right. The next thing we need to talk about is that acids are electrolytes. Electrolytes, okay? And if you're not sure what this is, we'll probably discuss this a little bit later as we get into it, okay? Most of your bases are also electrolytes, okay? And if you guys don't remember, electrolytes, this means that when you dissolve an acid or a base in a solution, they will conduct electricity. So I'll put here in solution, and I abbreviate solution SOLN, we'll say they conduct, okay? Same thing over here. We'll say in solution, they conduct, okay? And if you have questions about this, please ask. The next thing we need to talk to you about is that your acids are going to react with, okay? So these are going to react with metals to produce hydrogen gas, okay? Okay. And over here, your bases, they don't really react with metals. So that's why sometimes we use bases for certain reactions versus acids, okay? Now, your bases are going to feel slippery, okay? Which should make sense, because how do your hands feel when you put some soap on them and stuff? Don't they usually feel a little bit slippery? So that's definitely a property of your bases. And then the last thing we want to say, the word you want to use for acids is that they are corrosive. And your bases are going to be what we call caustic, okay? And all of these will also cause chemical burns on your skin. All right, so now I want you to make this little line here, and I want you to draw it all the way across to here. Okay, you see the line there? All right, so what this is going to be our pH line, okay? So make a little line here. This part right here, this is 7. This is going to be neutral. We're going to go over here, we're going to put a 0, and over here we're going to put a 14, okay? So all your bases are on this side, and all of your acids are on this side over here. All right, so if we had a solution, let's say right here, if we said that this was 1 molar HCl, it's going to have a pH of around 0, okay? Now, over here we've got, let's say our pH right here, let's say this is a 2. This is going to be stomach acid. Now, I'm not sure if you guys can read what I wrote, but you hear me saying at 2, you're going to write the word stomach acid, okay? If we go a little bit higher, let's say maybe at a pH of like 3, right here, this is where you're going to have vinegar, okay? What else do we have? Milk, I believe milk, if we have a pH somewhere over here of about 6, this can be milk, all right? Now, if we go up here to a pH of about 8, this is going to be your milk of magnesia. And I'm just going to abbreviate that. But this is kind of like your Pepto-Bismol or something like this. So if you have heartburn or something, you'll take a milk of magnesia and it's going to have a pH of around 8. If we go up here to a pH of about 11, this is lye soap, okay? Lye soap it's pretty bad stuff. It will if you guys have ever seen the movie Fight Club, the guy puts it on his hand and it causes a chemical burn, okay? And then up here, if we said that we had a pH of 14, this would be about 1 molar sodium hydroxide, okay? And so we'll get a little bit more. And if you want, you guys can fill these in as we go through some of the labs that we're going to do. You can fill these in a little bit more. These are just a couple of examples initially, okay? All right, so the next thing we need to talk about is we have strong acids and we have weak acids, okay? And what I'm going to do, I'm going to tell you, I'm going to give you, oh, I spelled strong. Okay, sorry. These are all of your strong acids. Now, what you need to understand is this. If it is not a strong acid, then it has to be a weak one. So there's only 6 strong ones, and so I'm going to put a 6 here. There's only 6 strong acids, so you know that if it is not a strong acid, then it must be a weak one, okay? So you don't have to get that confused. All right, so your strong ones are going to be HCl, HBr, HI, HNO3, so we have hydrochloric, hydrobromic, hydroiodic, we have nitric acid, we are going to have HClO4, and then we are going to have H2SO4, okay, sulfuric acid there. So these are all of your strong ones, okay? So if it's not a strong one, it must be a weak. So what is important about strong acids, okay? And so this is the key. These will, okay, ionize, or we also say another word is dissociate. So we'll say ionize or dissociate 100%. This is extremely important and this is extremely key, okay? So what this means, okay? So if I take HCl, okay, and I put this in water, right? So I'm going to dump some of this. This is going to be a solution, or it's going to be a liquid, okay? I'm going to put it into water. What happens is this breaks up into ions, and so you get an H plus. Remember, this is your cation plus Cl minus. This is your anion. You have 0% here in solution. You have 100% here. Okay? So this right here, this is strong. So you can label this. I don't know if you'll be able to read that on there, but this right here says strong. Okay? So you have HCl, it dissociates or ionizes into H plus and Cl minus. 0% here, 100%. So all of it is going to be an H plus and a Cl in the solution. Now, right, weak. Okay? If it is a weak one, you're going to have, like, let's say HF, okay? It's not one of our 6 strong, so it has to be a weak acid. So this is a weak acid, and what happens is it dissociates only a little bit. So you're going to get H plus and you're going to get Cl minus, but this is only about 5%, okay? Hopefully you can read that, but this is 5%. 95% of it stays as HF, okay? And so as we go along a little bit, it's going to become more important, it's going to become more evident. But the reason is because when we look at pH, we're looking for, as we set up here, right? This donates an H plus, your acids do. So if it's a strong acid, it's going to have a whole lot of H plus. If it's a weak one, it's not going to have very much H plus, okay? So just keep that in mind when we talk about it. All right, so then we're going to have the same thing over here. So now let's list our strong bases. Okay. So our strong bases, okay, these are going to be group 1 metals plus OH minus. Now, if you guys remember OH minus, this is hydroxide, okay? So you're going to have lithium hydroxide. You're going to have sodium hydroxide. You're going to have potassium hydroxide. What's next? You're going to have, what do we have? Rubidium? Yeah. Rubidium hydroxide, cesium hydroxide, and francium hydroxide. Oops, can't see that. Sorry. Right, so these are all your group 1 metals. Do you have to memorize that? No, because if you look at group 1, the only thing that we're not going to say is in group 1 as far as metals, right? Because hydrogen is not a metal. I don't think I have a periodic table over here with me. Yeah, I do. Hopefully you guys can see this. It's not too shiny. Okay, so, oops, it's a little shiny. Let me cover it. All right, so you can see there's lithium, sodium, potassium, rubidium, cesium, and francium. These are all your group 1 metals, okay? Now, your group 2 metals. Oh, it's shiny. Is going to be calcium, strontium, and barium, and that is it, okay? So those are the only ones that are going to be your strong bases, at least that you need to worry about for what we're talking about, okay? So your group 2, I'm going to abbreviate group, is GRP. Group 2 is going to be calcium hydroxide, strontium hydroxide, and barium hydroxide, okay? All right, so that being said, and we're going to have the same thing over here, okay? So let's say that I have something like lithium hydroxide, and we said this was strong, right? It's going to break up into Li plus and OH minus. We get 100% over here, and we get 0% here. And again, that's because this is a strong base, okay? If I go to something like, let's say I have magnesium hydroxide, okay? So that's MgOH2. This is a weak base. Okay, so we're gonna get, this is gonna be about 95% is gonna be in this form. Okay, only about 5% will ionize, so you'll get Mg2 plus and OH minus, and you'll have 2 of these. Okay, and so this will only be about 5%. So again, this is gonna have 100% ionization or dissociation. This will not, because it is a weak one. All right, so now what I need you to do, we're going to take this, and you see what I'm doing? Let me back this out a little bit. I'm taking this and I'm flipping it over to the back side. Okay, good. All right, so we are now on the back side. All right, so the first thing I'm going to do is I'm going to give you a couple of definitions. Okay, this is what we're going to call let me make sure I spell this right. This is what we call an Arrhenius. These are your Arrhenius definitions. So you have Arrhenius acids and bases, and you have Lewis acids and bases. You have a whole bunch of different ones, but we're only going to talk about Arrhenius, and we're going to talk about Bronsted-Lowry. And this is your basic definition of acids and bases, okay? So for an Arrhenius, this was a scientist, and this is what he discovered. He said that the definition for an acid, okay, is it's going to be anything that donates H plus, okay? So anything that donates an H plus is going to be your Arrhenius acid, okay? So now let's talk about an Arrhenius base, okay? And what he said is that an Arrhenius base is only going to be anything that has an OH minus, okay? So it can be any metal, so OH minus plus a metal. Oops, can you read that? Okay. So this is going to be your Arrhenius bases. Okay. Basic definition of them. So if I give you an example, we talked about this. If I give you H3PO4, okay? This right here, this is going to be an acid, and it's because it starts with H, and this is going to dissociate, and it's going to give you it's going to donate H pluses in a reaction, okay? We could say another example for a base for this would be if we had something like, we talked about this, you have sodium hydroxide. This is going to be, you've got your OH here and your base there. Basic definitions of that. Now, let's talk about, this is going to be Bronsted and Lowry. All right, so with Bronsted and Lowry, their definition was a little bit more advanced. And so what they had said was that an acid, this is going to be, now this is great because it's the same, It said it's anything that donates NH+. And I want to make sure you guys understand this. When we say this, I want you to also write proton here, okay? Because this is what this is. It's all it is a proton. Okay, so it donates a proton, right? Now, the definition for a base. This is where there's changed just a little bit, okay? This is where we're going to say, this is going to accept. It's going to accept protons, okay? So, and typically what we know about these are going to be able to, they accept protons. They're going to, typically are going to have an extra pair of electrons. Okay, and we'll talk about that a little bit further, but so your basic definition of your Bronsted Lowry is that this is going to accept protons. So this changes a little bit because I'm going to give you an example here. NH3, and we know this nitrogen has a lone pair of electrons up here. When you add H plus to a solution of ammonia, this is ammonia, you guys know this is the stuff that you guys clean with, okay? When you get this, a lot of times this is actually going to accept a proton, and so this becomes, NH4 with a plus charge here. And so that's what kind of makes this, the definition changes a little bit because it's not just limited to OH minus. So there's other bases besides OH minus. Okay. All right. So we're good there. I want you guys to go ahead. Let me back this back out. We're going to flip this over, and then you're going to open it up to the inside. Okay. So now we're going to be working on the inside portion of this. So we're going to briefly talk about, and you guys are probably going to have to pause this because you're going to need to draw these. Okay, so I already have them in here drawn for me. But what we're going to say here, this is going to be what do we call these? Bubble map, something like this, right? So right here, this in here says strong acid. Okay. And this in here is going to say weak acid. I'm not 100% sure if you guys can read this, but what I need you to write in there, and I'm going to show you a form, so you might want to pause this so that, well, you also need to write this too. You need to have your number line listed again, and we're going to say here's 1, here's 7, and here's 14, okay? At your pH of 1, you have a higher concentration of H plus than you do of OH minus, okay? As you get to 7, the amount of H plus and your amount of OH minus, these are going to be equal. And then when you get over here to pH of 14, your protons are going to be equal to your concentration of hydroxide ion, okay? So you need to draw this in, and then down here at the bottom, what we're going to have here is the same thing. You're going to have strong base, you're going to have weak base, okay? You got these 3 here in the middle, and we got the 4 outside and the 4 outside here, okay? So take a minute, pause it, whatever you need to do to get this stuff written down, okay? And then now I'm going to go ahead and go on with the lecture for this, okay? So what you need to fill in. All right. So we're going to talk about just for right now, we're going to talk about your strong acids, okay? Pull this out just a little bit. All right, so for your strong acids, we said that these dissociate or ionize 100%, okay? So, and that means that they're going to break up completely. So this means that you're going to have a high concentration of H plus, okay? So that says H plus there. So you're going to have a high concentration of H plus. You know what? I already have this done. I'm just going to show it this way. Okay. So for this bubble right here, you're going to put a high concentration of H plus, and that means because it dissociates 100%. So if you want to add a little note to this saying that this dissociates or ionizes 100%, that's what your strong acids do, okay? Now, because they dissociate that much, they are also going to be very strong electrolytes, okay? And remember, in order to conduct electricity in the solution, you have to have your ions. In particular, you need to have your cations, anions in there. The reason that an electric current can travel through a metal is because they have the delocalized electrons. So you've got your electrons, and they've got the positive charge that your electrons are able to flow through, okay? Which is why in a solution we have pluses and minuses are able to go. So this is why we call this a strong electrolyte. Down here you're going to write that you have a complete ionization or dissociation, okay? And we're going to also say that your pH is less than 3. And again, this is for strong acids, okay? Your pH is definitely going to be less than 3. Right? So I'll show those one more time. pH less than 3, complete ionization or dissociation, strong electrolyte, and then you want to say that it's got a high concentration of H+. Okay. Now let's go over here to this other side of this, and let's talk about our weak acids. Okay. So we're going to say that they have a low concentration of H+. And this should make sense to you because they don't dissociate very much, so they're not going to ionize, and so you don't get a lot of H+ in there, which is why the pH is lower. When we measure pH, we're looking for the amount of H+, okay? So you should remember that when you say pH because it's got the H in there. These are also going to be weak electrolytes, and that's because there's not very much H+. It's going to stay together as a compound, and so there's not very many electrolytes for the electricity to flow through. So these don't conduct electricity as well. We have incomplete ionization or dissociation, okay? And then your pH here is going to be less than 3, right? So with all that being said, what is it that these have in common? So if we go to what's in common, okay, let me pull this up just a little bit. All right, so here you've got your strong acid, and here we've got our weak acid. What they have in common is both of them are going to donate NH+, okay? Second of all, there are going to be electrolyte solutions, and we see dissociation or ionization, okay? So these are the things that they have in common, right? Now let's go down to, maybe show you this again. All right, so we've just filled in the top part of your chart here. Now let's go down here to the bottom part, and let's talk about our bases, okay? So for what you need to know with the bases, and I'm going to cheat a little bit, and I'm going to cheat across that out, and I'm going to put bases. Okay, so your strong bases, okay, they're going to have a high concentration of, and this says OH minus, okay? So strong base is going to have a high concentration of OH minus, okay? And this is great because it's the same as your strong acids, right? They are going to be strong electrolytes. Did I spell it? Electrolytes. Okay, I think I spelled it right. Right. So these are going to be strong electrolytes. Also, we're going to say that they have complete ionization, or the other word we use is dissociation. I'm going to abbreviate it there. And last but not least, we're going to say that the pH here is going to be, we're going to say that the pH is going to be, it's going to be greater than 7, okay? But it's going to be less than, so the pH here is going to be, let's say it's going to be less than about, what am I going to go with? Maybe 10, something in this range, okay? And these vary just a little bit. All right, so now let's go over here. I'm changing this to base. Okay, so we're going to talk about the properties of our weak base, okay? So if our strong base had a high OH minus concentration, this is going to have a low OH minus concentration, okay? So, you know what? I made a mistake. Go back here. Sorry. Scribble this out, fix it, whatever you need to do. Your pH here for your strong bases is going to be greater than 10. I made a big mistake, sorry. Greater than 10, okay? Because if it's strong, it's going to be closer to that end we talked about over here. It's going to be, your strong bases are going to be over here, right? So if this is 10, right, they're going to be up in this area. All right, sorry. I made a mistake, it happens. Okay, so this is going to be a low OH minus concentration. These are going to be weak electrolytes, okay? And they're going to have incomplete, or you can say partial, whatever makes sense to you, okay? So they're just going to dissociate a little bit. So incomplete or partial ionization. Or the other word you can use there is dissociation, okay? And what else? Last but not least, what do I want to put here? I want to say, okay, so this is where I need to do the other one. The pH here. All right, so this is going to be greater than 7, but the pH is going to be it's going to be less than 10. Okay, so you got kind of that 7 to 10 pH range is what you're going to see for your weak bases. All right, and then if we go to what they have in common, so I'm going to pull this out just a little bit. So what are the things that they have in common? Both are going to have OH minus. Okay, what else did we say? They are both going to be electrolytes. Put E in there, and they're going to dissociate or ionize. Okay, whoops, there you go. So they're going to dissociate or ionize. All right, so those are the properties. Now we need to go to the next part. So I hope you guys aren't tired yet, because there's lots more to do. All right. Now we're going to talk about some of the reactions that we have with our acids and our bases there. So go to, where's the one I've been writing? Sorry. All right, so here's the one I've been writing. Okay. So here's it. Go to the back side. So here was your front side, right? We had a bunch of stuff that we wrote. So you have this in the middle, right? And then we're going to go to the back side where you wrote this Arrhenius, Bronsted, Lowry, and that stuff, okay? You should have a little bit more space here at the bottom. What we're going to talk about here now is we're going to talk about the reactions. Right, so these are your reactions that happen. And so these are going to be all of your acid-base reactions. I'm going to say all, but most of your acid-base reactions, we're going to say that they are double replacement or displacement, okay? Now, the other word that you need to know for this is neutralization, okay? You may have to ask your teacher if you can't read my handwriting. I understand it's not beautiful. This is neutralization. So anytime you add an acid and a base, typically you're going to neutralize something. Not always, because sometimes we have a strong acid and we take a weak base, and that's another story, but we're not going to get into that. So let me give you an example. What we have here is if I take, oh, and this is the other thing you need to know. This is extremely important, okay, because you're going to be asked this question. If I take an acid, gosh dang, I can't spell today. If I take an acid plus a base, okay, there are two products, okay? There are two products that you will always get, okay? Inevitably, this is what you will get. You will get water as one, okay, plus a salt. Now, remember, when we say salt, we mean ionic compound, okay? Ionic compound, and remember, an ionic compound is a what and a what? I hope you're saying it's a metal plus a non-metal, okay? Don't forget that. Right. So here we go. Let me give you a simple example. So if I take HCl, okay, plus NaOH, and how do I know that this is an acid? Because remember, it's going to start here with H, right? So this is my acid plus my base, and it's got an OH minus in it, right? So this is your hydroxide, so we know this is my base. So I take my acid plus my base, and over here, we said this was double displacement, so remember this one. So my cation is going to switch places with my anion, okay? So the plus has to go with the minus. We always have to have plus and minus together. I would never put this H plus with this sodium, because that's two cations together. That's not going to happen. So my H goes with my OH, and then I'm going to take my Cl, and this needs to go with my Na. And remember, when we write these, we always put the cation first, so the positive one first, and the anion is going to go second. So this is going to be HOH. You commonly know HOH as H2O, right? This is water, okay? And to this, we are going to also put our other one, which is sodium. I messed up. Sodium chloride. Okay, this is Cl minus. Okay, so let me just scribble this out because it's ugly. All right, this is NaCl. So NaCl, this is my salts, because look, it's my metal plus my non-metal, okay? So there's one other thing that you need to understand, you need to know with these, and so we're going to do some practice stuff, but when I'm just giving you the notes, you're going to have to go back and look at these when we go through the practice problems. But we have what's called, we labeled, let me give you another example here. Let's say we have sulfuric acid. So we're going to have H2SO4. And to this, we're going to add, let's go with lithium hydroxide. Okay. So I've got my acid. So I'm going to label this. This is my acid. I've got my base. Okay. And then over here, we already know that one of the products, so we're going to get, if we go like this, right, we're going to take your cation plus your anion, and so we're going to get HOH, which we know this as H2O. And the other thing we're going to get is plus Li. Remember, this has a +1 charge. And our sulfate over here, this has got this 2- charge. So when we cross these, you're going to get Li2 SO4. Oh, you can even see it. So we cross this, right? We put this 2 down here, and that's where this 2 comes from. So this is your salt, because you've got your metal and you've got your nonmetals here. So this is lithium sulfate. And here's what you need to understand about this. So if we come back over here, my OH, right? It came over here and it picked up a proton. So this is why we called this a base. Over here, and then we took our sulfate. The sulfate came over here and it's bound to the lithium. So this is going to be my conjugate This is my, so this picked up, we said that the OH minus picked up this proton. So this is now, this was the base, and now becomes my conjugate acid. Okay. And over here we have our conjugate base. Okay. And we'll explain this a little bit more to you, but the reason is because if I go backwards in this equation, okay, this SO4 is going to come over here and it's going to steal this H+. So it's going to steal this H+, so that it now becomes H2SO4, right? And then this lithium and the hydroxide is going to go back together. So this picks up a proton, which is your definition of a base, okay? And we'll spend a little bit more time to do that, but what you have to know is whatever the acid was, when it comes over here, the anion portion is going to become your conjugate base, okay? And whichever one over here was your base, okay, so OH was the base, it's now going to become your conjugate acid, okay? So they kind of switch. And we'll talk a little bit more about that as we go, right? Let me think, what else do I need to talk to you about? Let's also talk a little bit about, okay, so we wrote this in here. I want you to open it back up. So I don't have anything on the middle. I wrote it on different paper, but all right. So when I open this up, I go back to my middle section, right? Take this flap over here, and we're going to talk about your pH calculations. So we're going to talk a little bit about pH calculations. You know what, though? I'm going to save this, I think, for next time. So hold on to this, and we will talk about your pH calculations next time.